this up myself, but like the history of the endocannabinoid receptors, how they got named, because there's, I would say, possible myths in the cannabis industry about how they came about, and I'd like to hear it from a scientist perspective.
Well, but I'm not really a history researcher, actually. I'm not really sure for the history, honestly, because those kind of thing has happened really long time ago, right? That is like even the first cannabinoid receptor has been even cloned on the 1990s, and that was the time that people were crazy to clone those receptors, not only for the cannabinoid but also for the opioids or whatever.
Okay.
So on 90s, that was really the crazy time that the cannabinoid receptor type 1, CB1 has been cloned, CB2 has been cloned, on the same time that the death opioid receptor has been cloned, mu opioids and kappa, so on. So that was really the really the beginning of all those the receptor research or the drug-related receptor research.
I feel like I'm going back to my med chem class, which is not my specialty, but were the naming conventions like they just found a molecule that was a strong binder and therefore that became the endocannabinoid receptor?
Right. That's
yeah,
that.
Okay.
That's that. No, actually that all those research really started by really the discovery of the receptor itself, and not only by the cannabinoid but also for the opioids, whatever as well. I think it was like opioid was the first one. The first question that people had was, okay, the people get drunk, people get junkie, or people get whatever by those kind of the drugs, and that might mean that there should be somewhere which receives such a drugs in the body, and there should be some kind of region or the whatever protein or whatever, they never knew that, but at least binding point of such kind of drug. So that's how everything has been started, I think. And I think radio labeled, I think that was morphine. I'm not pretty sure though. They radio labeled those kind of the opioid or whatever, and they tried out if there's any kind of the place that such a kind of thing will bind on the slice or whatever. And actually they could find, on the cell surface of the cell, there is indeed a place that specifically those stuff can stick on. And that was the time that they started to call as a receptor.
Gotcha. One of the things about naturally occurring CBD that it might be problematic for you is that it typically co-crystallizes with CBDV.
Yeah.
So even our stuff typically will have some 0.1 or 0.2% CBDV in it as well. And I never had thought about that from the pharmacological perspective, which is choose your poison, right? You can get it from the plant and have this issue of CBDV co-crystallizing, or you can try to do the synthesis and you're gonna get an enantiomerically pure. I don't know. I actually haven't thought about that synthesis in a while. I don't know if you have diastereomer issues too or what, but all I know is it's not a fun synthesis. It's not very good. So that's an interesting choice that you kind of have to make, is whether you'll accept a little bit of CBDV. I mean, you can get it out chromatographically, but
no, true. And that is another reason that actually I'm not really testing your stuff, but also trying for the other isolates which has been used for another product in Japan too. And I think such a kind of if there's any kind of the difference in vivo, then that will be kind of interesting as well, right? I mean, if there's no difference at all, that's fine. If there's kind of the difference, that will be fine as well. But which kind of the context, that will be the point, I think.
Yeah, that would be, again, that would be really interesting. We're sitting here in our thrones saying there's no difference, but maybe there will be.
If there will be.
I happen to think, like, when I first was working on this, I couldn't in my head come up with any reason that RO water, chemistry-wise, would be better, because all the contaminants are water soluble. They go out with the filtrate, and I ended up getting a 4% purity bump when I switched to RO water. So who knows? It's always important to do the experiment instead of just thinking you know how it'll work, I guess.
Right.
Yeah.
So really, why not?
Yeah, why not?
I mean, the cannabinoid receptor itself is quite strange in my eyes. Sometimes that let's say the cannabis-derived cannabinoids are kind of strange sometimes. That they shows completely different stuff than let's say the chemical agonists pretty often in context of inflammation, for example. So the immune system reacts completely different to the natural cannabinoid or the synthetic cannabinoid. I've seen that one of the recent papers which was really interesting, that comparing THC to the synthetic CB1 agonist, and they both showed completely different stuff. And I have my feeling that the CB1 and CB2 can accompany together, even if they're said that they do express on the totally different place. I have my feeling that they two can kind of crosstalk with each other, and probably the cannabis-derived the cannabinoid is something that which can drive or push such kind of the crosstalk or the cooperations. That's actually my kind of hypothesis or my feeling, but I do have this strong feeling like that.
Is it possible that it's just off-target non-endocannabinoid interactions too?
Maybe, yes.
Okay. Yeah. But sorting out what the causes of what on your end of stuff is hard, I'll say.
I know. Well, actually, that is one of the reasons that now I'm generating a lot of the genetically modified animals. I mean, the CB1 knockout, CB2 knockout, the double knockout of the CB1, CB2, and also for the region-specific knockouts, I do have the fox animals as well. So, like a whole set of those kind of animals.
Oh, expressing and purifying proteins and doing binding studies with, isothermal.
In vivo.
Yeah, isothermal titration calorimetry. Are folks doing that with the endocannabinoids? In vivo binding studies, trying to figure out why it might be that a cannabinoid would behave differently than a synthetic cannabinoid, agonist, antagonist, target molecule of some sort. Is there any insight from looking at it at that level why they might behave so differently?
Yeah, actually, binding study with the cells are really the first step, right? And pretty many people are already doing, and pretty many people already done that. And therefore there is indeed a very nice data table already, like which phytocannabinoid, for example, will stick on which kind of the receptor, not only for the cannabinoids and so on. If they work as the agonist or antagonist, not only for the binding, but the agonist or antagonist, that is also known for a lot of the cannabinoid as well. What is not really known is what the hell will happen on the receptor level in the body.
Yeah, now that you mention it, I have I'm having images conjured up of seeing papers where they add one carbon on the chain, and they've done the SAR stuff already. You're pretty much saying it's over and done with and boring, and now it's on to the harder stuff.
Yeah. Well, yeah.
Yeah.
So Chihiro, is there any of the cannabinoids that you are more excited about, or think have more potential than any of the others?
That's really the hard question, honestly, because my feeling is each of them has the advantage and disadvantage for sure. One can go better than the another in different contexts. So
what do you mean by you saying advantage and disadvantage to you?
I mean that how to which kind of the symptom it does work, or which symptom can be improved by which cannabinoid can be different. That's the point. So each of them has their characteristics, each of them has their advantage, and each of them has their strong point. So the one cannabinoid can, while one cannabinoid can improve some sort of the specific particular symptom or pathophysiological symptom, it is very possible that another one can worsen that pathology. Who knows? No, seriously, who knows? So that is one of the reasons I say I have no idea, because even that the receptor itself do work in the opposite way around in some cases. Actually, for example, that even in context of the inflammation, for example, sometimes the receptor do work for the worsening of the inflammation. In another case, it works for preventing of the inflammation.
And
Same
that
receptor.
Depends on what molecule is binding with the receptor.
Well, actually, I have no idea that it's really only the case. So which kind of the signaling action is working in between, starting from the receptor or whatever. So it's really complicated, actually. The cannabinoid receptor research itself and what they are doing in the body is pretty complicated. It really depends on the region. It depends on where they are. It depends on how they are stimulated. So yeah.
What's your opinion on the entourage effect? Have you done
entourage
any
effect.
research
Yeah.
with broad spec?
Actually, yes and no. Because I know that it's not only about those kind of cannabinoids, but also for the other kind of drugs. That it is really known that if different kind of, for example, opioid has been combined together and given together, that the effect will not go double, but sometimes like a triple or something like that. So that is kind of the entourage, right? That because of the effect itself is not doubling, but yet it's more enhanced. So honestly, entourage itself is not so special for me, to be honest. Very honestly speaking, it's not very special. It's not very special. That it can happen for any kind of the drugs. It can happen for any kind of the molecule which has the pathophysiological effect. And if you say why about that, then I will say that because of our body is pretty complicated. The receptor is not working by itself, but it sometimes forms like a dimers, like a homodimer or the heterodimer, or even I've heard like a heterotrimer. Sometimes they form like a heterotrimer to do something else. And some of the nobody really knows that how those heterodimers or the heterotrimers are really formed in the body, and if they are really working, doing something specific in our body. Well, I have no idea how can we demonstrate that kind of a thing, but this is just one kind of example for complexity in the body, or the biological complexity.
Right, and your research on CB1 and CB2 receptors, are they mostly on I believe it was the immune cells, isn't it? The white blood cells and the neurons, so your brain cells, or are those receptors found in other parts of the body?
But for the CB1, for example, that they are really expressed a lot on the fat, not really a lot, but some of them are expressed on the fat tissues. Not so many, but it is indeed they are expressed on the fat tissues. And if you specifically delete those kind of fat tissues, what will happen is they drastically reduce the fats. So even if that they do express a little, that does not mean that they're not doing anything at all over there. And that is one of the complexity for the cannabinoid receptors as well.
Right, and CB1 and CB2, there's more than those two receptors in the body?
What do you mean?
As far as cannabinoid receptors. I believe I heard that there are more than just CB1 and CB2 receptors.
You mean that if I'm thinking that if there's anything else is happening by the other kind of receptors?
Yeah, I mean, I just remember reading an article. It was a pretty old article, but they believe that the endocannabinoid system was, potentially involved in most of, human disease.
Right.
In one way or another, and that is just the CB. I'm sorry, I'm trying to remember your paper. I believe it was the CB2 receptors being on the white blood cells. That's how that manages to affect such a broad array of conditions.
Well, actually, these such a kind of the division, such kind of the definition, or such kind of the separating does not mean anything at all right now because of the. Well, again, that the very small population of the cannabinoid receptors can do something, can give pretty drastic stuff. One of the things I know is that the CB2 receptor, which is expressed on the neurons, which is believed to do nothing because of the expression level is so low, super duper low. But now that, actually it's my ex-colleague's work, that she found that without such a neuronal CB2 receptor, I think that the animals couldn't remember well or something by the aging. I don't really remember though. But the fact is that the small population or the large population does not mean anything for the cannabinoid receptors.
Interesting. So you don't really need that many cannabinoid receptors.
Right.
For those animals that can remember for a long time.
I have to check back the paper actually. But the people actually believe that it's more the CB1 receptor which can affect the brain function because of it's one of the abundantly expressing GPCR in the brain. But all the way around, and the CB2 is not that expressed in the neurons. That it's very, very small, super duper small population on the CB2 population on the neurons. But without those CB2 receptors, there is indeed the significant difference or the significant, I think, decrease of the brain function. So we cannot ignore such a small population.
Right.
So that I think that is one of the hard and complex point of using on the cannabis as a drug. Why? Because of the small or not, no matter that they do something pretty huge to our body, and this is kind of the same in context of endocannabinoid as well, because the endocannabinoid there is a 2-AG anandamide, right? And the 2-AG. There is indeed a lot that the 2-AG, the 2-arachidonyl glycerol and the anandamide. The point is that the release level at the anandamide is, I think, 1,000-fold lower than 2-AG. 1,000-fold lower. So it's very, very, very little. But this super little amount of the anandamide pretty often do more bigger stuff than the 2-AG, which is released like 1,000-fold more.
Right. Are those compounds you were discussing? Those are cannabinoids that your body releases.
Yes, and it's actually
endocannabinoids.
Endocannabinoids.
Right.
But if the endocannabinoids do like that, then why not for the cannabis-derived cannabinoids as well? Who knows? Really?
Right.
Who knows?
Right. Do you have any insight into how the endocannabinoid system may have developed in humans? Like why we have an endocannabinoid system and what function it serves, or how it got there?
What means of the development actually? Because of the development means like growing up from the baby to the adult, or the evaluation stuff.
No, I was thinking more like in the evolution of the species.
Evolutional.
How we ended up with it.
Yeah,
how we ended up with these receptors in our body that interact so well with this one particular plant.
I don't know that I have no idea honestly, but one of the thing for the my feeling is more like the body first then cannabis later. That it's just the God's sake that there is indeed a plant extract that which binds a lot or which can affect a lot for our body. I mean the animal's body, but because of the interesting point from the endocannabinoid stuff is that it's a lipid ligand. It's a lipid. Mostly those neurotransmitters or whatever, which is really important, those are the amino acids or the chemical amide. It's amides, never the lipids. But the endocannabinoids are the lipids. So they just evoluted like using the lipid-based molecule as a signaling molecule, and that's just again the God's sake that it fitted to something for the cannabis plant. And that is it.
Are there other plant-derived compounds that fit that profile?
For the cannabinoids?
Yeah, or just generally, you were just talking about how use lipid compounds
for the signaling molecule.
Kind of a unique signaling molecule. Are there other plant-derived things that kind of fit that?
Well, actually, most well-known one is one of the terpene that everybody knows, that the beta caryophyllene.
Yeah. Okay.
Because the beta caryophyllene is not only the terpene. This one is a clear, selective, potent CB2 agonist. Super selective and potent. It's really comparable to the synthetic CB2 agonists. So that is one of the good example, I think. And even for the CB1 receptors, I mean, that's like to get psychotropic effect. Like I heard that some of the plant stuff, like an extract from the moss, some sort of the moss, there is indeed some sort of the extract that which binds for the CB1 receptor and activate them. Also, there is indeed some other stuff. I don't really remember, but I remember that there's a multiple plant extracts that does bind for the CB1 as well.
It's interesting. Anecdotally, people report pretty different effects from distilled cannabis oils than full spectrum and beta caryophyllene might be removed during that process. I guess it's dangerous to connect those two things, and agate, but you know, if you're hand waving and acting like a scientist to the layman, you can just make those claims.
True.
One question I thought was interesting. So, are there any pharmaceuticals or mainstream drugs or compounds that are designed to interact with the endocannabinoid system, with the exception of like Epidiolex, which is essentially CBD isolate, or Sativex, which I believe is THC distillate?
No, I think that before that one really well-known stuff was Rimonabant. That was the CB1 antagonist, which went on the market like decades ago and it has been banned pretty soon because of the severe side effect. It was antagonist and it was to reduce the appetite. But it was a diet drug. So to be lean. Seriously, I'm serious.
So it's an antagonist to the same cannabinoid receptors that.
Right. So the blocker of the CB1.
They give Marinol to my grandmother so that she'll eat when she is in hospice, and that is the opposite effect.
Right.
Yeah.
What is Marinol? Is Marinol D9?
Synthetic D9.
Okay.
Yeah. That one. That's another thing, right? That I think there is synthetic D9 as well, not Naviron or something. I don't really remember the name, but I think up to now there is 4 possibility for the medical cannabinoid drugs. I think.
You're talking about one.
Nabilone, yes. One is a Nabilone. It's a Sesamet. Its drug name is Sesamet, and the molecule name is a Nabilone.
Do you know anything about it? Have you done any research with that or know how it works, anything like that?
Oh, you mean the Nabilone?
Yeah.
No, never. Actually, never. I've never been using this one. Well, it looks like kind of interesting, but I have no idea that if we can get this or not. I don't think so, honestly. But probably if I will get the license for those narcotic research and so on, and then maybe yes. I have no idea how can I get this though, but yeah.
So I'll come make it.
Yeah.
Yeah, you're the chemist.
Shahiro, you're gonna have to learn how to be a farmer if you get that permit. Wasn't that the permit you were talking about where you have to cultivate your own crop and extract it and then you can do the research?
No. That is for the cannabis research. I'm talking about the narcotic research.
Oh, okay. Gotcha. Oh, that's right.